The next example has one predictor, and it's going to be a continuous predictor instead of these zeros and ones. So let's say we're trying to predict college GPA based on high school GPA. And I'll call this X, just so I don't have to write high school GPA so many times. And so I have data from a bunch of students, and these are both continuous, right? So now my data might look like this. It's no longer true that my data points have to come in columns like this, because high school GPA could be anything from 0 to 4. Hopefully there aren't too many GPAs all the way down there near 0, but I want to fill in the whole space with my drawing, so that's what I did. So now, if I want to come up with a model, how am I going to do that? Still going to be a model for the mean. The mean of y, given that you tell me x, I'm going to write it like this. Is equal to beta 0 plus beta 1 times x. If you give me x, if you tell me the high school GPA, then I want to be able to plug it into this formula, into this expression, and get back out my best guess at the mean of y given x. This is the equation for a line, right? This is just the equation for a line. If I knew beta 0 and beta 1, that's the slope and intercept of a line. Okay, so I'd be able to draw the line that way. So now, if I have this equation, mean of y, given that x is equal to a certain value, I'm just going to plug it in. Beta 0 plus beta 1 times 3.5, right? In other words, here's 3.5. Put it over here. Here's my prediction for the GPA of someone who, a college GPA of someone who has a high school GPA of 3.5. How am I going to estimate the slope and intercept? How am I going to do that? We're going to go back to this idea of residuals. But instead of thinking about whether I should compare a particular point to the overall mean or the mean in just one group, I'm going to think about whether I should compare a point to the overall mean or the point on this line. So if I have a bunch of data points, I have y1 all the way up to y1, y2, all the way up to yn. The equal means model would say there's only one mean here. I should compare each of these points to the overall average. The regression model, this equation right here, says that I should compare each point to what I would get from this model. So I have some estimate of beta 0 plus my estimate of beta 1 plus the x value for that first person. And for the second person, I should compare the second person's outcome to what I would get from the model if I plugged it in for the second person. And for this last person, that's their actual college GPA. And this is the college GPA predicted by the model if I have particular estimates of beta 0 and beta 1. If I were to just add up all these quantities, I'd get 0. They'd cancel. So I'm going to square them and then add them up. Same here. I'm going to square them and then add them up. This quantity right here is just the numerator from the variance of all the college GPAs, right? Take each college GPA, subtract the mean college GPA, square them, add them all up, and if I wanted the actual variance, I could divide by how many there are. But this numerator just stops short of dividing by how many there are. That should be squared. This right here is the sum of squared residuals. So if this is y bar is here, For each data point, I can either compare the data point to y bar, and that's going to be this residual, or I could compare it to the line. What's the vertical distance between that point and the line? That's going to be this residual. The way we select the regression line that's most appropriate is by trying to minimize this quantity. Trying to minimize this quantity. We try to choose the values of beta 0 and beta 1 as our estimates that make this whole quantity as small as possible. Because ideally, this line would be as close to the points as possible. Ideally, those residuals would be as close to 0 as possible. And so you can imagine, we have all these points. There's a lot of different possible lines that we could draw here, right? I can move the slope. I can move the intercept. Every possible line we can think of comes with a sum of squared residuals, and we're trying to choose the line that minimizes that quantity. To do a hypothesis test, what we're going to be doing is comparing this sum of squared residuals to this sum of squared residuals to say, do we have evidence to reject the equal means model in favor of the regression line model? That's the same as doing a hypothesis test to see whether this beta 1 is equal to 0 or not. To start with a null hypothesis that beta 1 is equal to 0. If I don't have evidence to reject the hypothesis that beta 1 is equal to 0, then my model just says the mean of y, if you tell me x, is just this one number. In other words, I only need one average. One number is my best estimate of anybody's college GPA, regardless of their high school GPA.